Have you ever heard of the idea that playing Mozart music or some other type of non-lyrical music improves your test scores on certain things? Well, you can also consider and wonder, maybe smelling a certain scent would do the same thing. So what we have here is we have some individuals who were randomly assigned into either taking kind of like a menial task. It's like did a maze. So they did this maze. And they were randomly assigned to either do scented or unscented first or second. So they were randomly assigned to, some were randomly assigned to do the scented first, and some were randomly assigned to do the unscented first. And then after they were done with the one, then they did the other one. So they wore basically like a surgical mask. And then they were timed to see how long it took them to do these different. Now it's different mazes, so. It's not like they could remember one and then do the other one. So, seeing is there a difference? Does using a scented mask improve your ability to take a maze test? All right. So what we're going to do is the question asks: do the data provide sufficient convincing evidence that a floral scented mask improved performance? All right. So. First off, we're going to notice and have to figure out what type of a test are we running. All right. So first and foremost, we notice that these are all done as times. They're in seconds. So am I doing a test for pi or am I doing a test for mu? And the answer is we're doing a test for mu, not for pi, because we're measuring something. We're measuring time. All right. And then, all right, so we're doing a test for mu, and then we have to ask, all right, well, what type of a test from mu am I running? And I'm going to have to go through my conditions here pretty soon. But first of all, is it a one sample or a two sample? And the answer is this is one of those problems that gets a little tricky to figure out, because you look at it and you'd say, well, there's two samples, but the reality is there's only one sample because it's one individual subject. So if we look at this individual subject, let's say subject number 6. Subject number 6, with the unscented, did it in 32, and with the scented, did it in 43.23. All right, so they took longer with scented. All right. So what I'm doing here is then trying to figure out, well, it's technically one sample because I'm doing what's called a paired test. And it's called paired because each individual subject has a pairing of two different scores. All right? And what I'm testing for is, did the mask improve performance? All right? So you have to figure out what does improve mean. So let's go to the next slide. All right, so first thing I did is I took the data here and I put it into, let's get this out of the way. Put it into two lists. All right, and then I chose to do list 2 minus list 1. So for me, that was the scented minus the unscented. And the more I'm thinking about this, I'm thinking, all right, well, does it matter which one I do? Do I have to do list 2 minus list 1, or can I do list 1 minus list 2? What am I trying to figure out? Well, to show that the performance was improved, an improved performance means that the second number should be lower than the first number. All right? And that would be an improved performance. And if I like having a positive number, I'm going to do this the other way. So what I've decided here is, instead of doing this, I'm going to do L1 minus L2, because again, if L2 is an improvement, it'll be a lower number, and so my overall average will be a positive number, and I like working with positive numbers. All right, so let's do that. And what I have then is I have now this person who actually did poorer, they did worse on the second one than they did on the first one. So that means that their time on the second one here, 37, was less, which means it was a negative number. And we'll see, like this person down here, they actually improved by 19.47 seconds from 68.47 with unscented, and they did an improvement of 49, so much less time with the scented. All right, so that's what I want to look at. I want to look at, for me, the unscented minus scented. Unscented. Am I spelling scent right? Unscented minus scented is my difference. You need to say somewhere in the problem when doing a paired test how you're actually doing your differences. All right, so then I can actually say, then start working towards, is there, and work through that test. So I'm going to start with my hypotheses, and I'm going to say that I think my difference will be greater than 0 because I defined difference as minus scented. All right, unscented minus scented, so scented would be a smaller number. All right, and I'm going to test my, oh, sorry, I did that wrong. Don't let me do that, folks. Don't let me go crazy like that. It's always equal in the null. My alternative is that my differences are greater than 0. Those are my hypotheses. And then I need to go through my conditions. My subjects were randomly assigned, and that's different than saying it was a simple random sample. So maybe these people were selected and they volunteered to be part of the study. So their random assignment into the two groups is very important because now this is starting to sound like a designed experiment. Randomization, replication, and control. There was randomization for who they got subject, which test they got first. Replication, we did this 21 times. And control, some got the scented first, some got the unscented first, and that was controlled. So this is a designed experiment. All right, but that's my first step for S for a random sample, simple random sample. It's not a simple random sample, but they were randomly assigned. If you were to say in a problem like this there was a simple random sample, you would get it wrong because it's not. All right, they were randomly assigned. Independence, so the N is 21, so 10N is 210. There are over 210 possible pairings of people. Unfortunately, one person response is not independent of their other responses. So just one person. So how they take a test with scented and then how they take a test with unscented is not independent because it's the same person. So I'm going to say that. However, of the 21 people, one person's score does not influence another person's score. Therefore, we still have independence. There's a lot going on here, so follow along. N for normality. I know nothing about the population distribution, so I cannot say anything about the sampling distribution yet. My sample size is 21, so I cannot use the central limit theorem. So then I'm like, oh, crud. So now I have to actually prove somehow that it comes from a normal distribution. So what I'm going to do is I'm going to take and I'm going to do a plot of this last one over here. This one's called a normal probability plot. And a normal probability plot, and mine was in list 3, will tell me, if I do one, what I can say about the original distribution. So after I make that normal probability plot, I need to actually graph it, write the graph, and then assess it. You'll see I did it with two things. I did it both with a box plot and also a normal probability plot. And what I'm going to say from this is since the NPP, normal probability plot, is approximately linear, therefore sampling distribution is approximately normal. All right. So now I need to shrink some of this stuff up. So we can get more information in. All right. Sigma is unknown. Therefore, use paired T. All right. So I'm using the paired T. Now recall, when I did this normal probability plot, it is only of the paired data. So all of my data that I plotted in there, all my dots are from the D list, my list 3, my list of differences. All right, because it's based on just a single sample, paired. I made the subtraction, so I just have that one pairing. So I'm going to do a t-test. So then I have to write. So I got this here, which I'll do momentarily, but I have to write the formula. T equals x bar, or in this case, actually, I probably should write d bar, the average of the differences, minus mu over s over root n. And that's the standard deviation of the differences. All right. And what I'm going to do is I'm going to use my graphing calculator, and I'm going to do a t-test. For my list of differences, my null hypothesis was 0. My alternative was greater than 0, and I'm going to calculate that and bring that out. I'm going to put the numbers into my formula. T equals, oh, and I had this one backwards. I must have done something backwards on my calculator. It should be a positive 0.34938. Oh, I know. I originally did this with my lists subtracted the wrong way. Minus 0, but that's okay. If I did it the other way, I'm still going to get the right numbers here. A couple things just changed slightly. Again, I'm looking at my thing and not actually the 0.9566 repeating minus 0 divided by s, which was 12.547, divided by the square root of 21, gives me a t-score of positive that's a positive 0.349. All right, and again, so I subtracted something incorrectly when I did this the first time. I did the two lists opposite each other. T 0 greater than 0.349. Okay, so maybe it's not quite that far, like this. All right, so when I did it the first time but the wrong way on my calculator, I got this number, 0.6, which is this area, 0.63477. So my area up here is still, what, like 36 point something percent? 36.52 something, 53%. That's my p-value. So I am, let's see, need to make a conclusion. Since we could see results as big as this, or bigger, 36% of the time, that means there is not sufficient evidence to prove that scented masks improve performance. Do not reject null. Remember, don't ever say accept the null. Never, ever, ever say accept the null. If you say accept the null, everything that you've done up to that point is for nothing. Cannot say accept the null ever. All right. What would happen though? What would happen? Let's say hypothetically that we had a p-value of let's say 0.03. All right, and in a case like that, we would say, oh, reject the null, accept the alternative. The follow-up question is, does that prove that scented masks cause an improvement I'm going to highlight that word cause because that's a very loaded word. So based on everything that we did in this problem, everything that we talked about leading up till now, and I walked you through some of my rationale ahead of time, I need you to answer this question and justify it based on your remembrance of that past chapter for causation, based on what earlier what I talked about in this problem. If you need to, you're going to have to go back and reread it. All right? That's all, folks. Reflection response. Fill this out as a good example for how to do a paired t-test. Later.